The broadcast is now starting. All attendees are in listen-only mode.
start over again, folks. Sorry about put in questions throughout the webinar if you have them. And if there's time left over, we will try to go through those. Our agenda again today is just on this slide. I'm still going to keep us to 30 minutes. We'll go a little bit beyond our 12:30 constraint there as well. And in this slide, again, I'm showing again some of the history of energy simulation, at least here in the United States, which I'm showing a time series plot from the mid-60s to the 1980s. And some of you will recognize many of the tools that are on this plot. You can see things like Trace, the beginnings of Trace 700 in the mid-70s, DO2 in the late 70s. There are others that I'm sure you'll recognize. What that really shows is that many of us are using simulation software that's what we would call legacy code. It really hasn't changed that much since the perhaps even the mid-60s and late 70s. And that's really not what I would consider innovation. And what we have with OpenStudio is a chance to innovate and bring innovation into our workflows and the way we approach energy simulation. And there's three reasons why we might want to do that. One reason would be we want to, again, differentiate ourselves from our simulation competitors, folks who we compete against every day. The second reason, again, we want to outcompete. We frankly want to be more efficient in our simulation tasks. And the third reason that we want to innovate is we want to be able to bring simulation into new markets, new marketplaces where in the past it may have been true that simulation was too costly or takes too much time or just simply too complex to be a use case. And I'm proposing that OpenStudio actually provides a pathway for innovation to occur where some of those barriers can be either reduced, in some cases even removed. So in this next slide, I'm showing the OpenStudio energy modeling ecosystem of tools. And you'll see on the right a graphic here, a little bit of a spoke hub graphic. In the center of the spoke is the OpenStudio SDK, and that stands for the Software Development Kit. And feeding into that software development kit, you'll see an acronym called TPEX, Technology Performance Exchange, also another acronym called BCL, which is the Building Component Library. Underneath that, you'll see four different icons for different engines, again, that OpenStudio accesses. One of those is EnergyPlus, the second is Contam, the third is ESP-R, and the fourth is Radiance. So some people like to think of OpenStudio as a middleware. It's really a middleware glue between not just energy simulation engines like OpenStudio, like EnergyPlus, but also a common energy model or object model that can be shared across several engines. So the same object model, the OpenStudio object model, serves EnergyPlus as an energy simulation engine, and it serves data to Radiance as a daylight simulation engine. In our conversations today, we're going to talk about four separate applications that are in this hub and spoke, four separate applications on the outer spokes, which are the OpenStudio server, the PAT spreadsheet, the SketchUp plugin, the OpenStudio application, and also PAT. And those are really user-facing examples, user-facing applications of OpenStudio. They are examples of applications that have been built on top of the OpenStudio SDK, Software Development Kit. Now, one of the things that's really unique about OpenStudio is that it's open source, hence the open in the OpenStudio. It's cross-platform. It will work on both Mac machines, Linux machines, Unix-based machines, and also Windows-based machines. And it's collaborative. And by collaborative, I mean that there are many other stakeholders, not just universities and national labs, but also private sector entities who are collaborating to build the OpenStudio ecosystem of tools. And that's really what you see on the outside of this wheel. Some of the collaborative applications, some you might be familiar with the DOE asset score, which is highlighted here. Density, again, another application. So this slide, again, is meant to show that there's a number of players, number of entities who are using the OpenStudio SDK to bring innovation into their workflows. So the next few slides cover some things that are very different about OpenStudio as you would compare them to other simulation tools. They're differentiators. This slide shows the OpenStudio object relationship, so model-object relationship diagram. Some of you might think, again, of OpenStudio as simply an interface for EnergyPlus. And while that's true, there's so much more going on. So let me just start here with this slide by focusing on this piece in the center here called the thermal zone. And again, anybody who's doing energy modeling is familiar with that term, what a thermal zone is. And OpenStudio certainly understands what a thermal zone is, but you'll see arrows going into that thermal zone. and those arrows come from objects that are called spaces. And a space is an object that exists in the OpenStudio object model. It does not exist in the EnergyPlus object model. So it's, again, a representation. It's a hierarchy. It's another object that does not exist in the engine for EnergyPlus. And it's really there because if you look at an individual space, here again in OpenStudio, you'll see, and it's a little hard to see, but spaces have properties attached to them. One of them is called a space type. If we go over to the right of the side, we see a space type. And a space type has, again, properties attached to it. And some of you might be familiar, again, with these properties, which represent internal loads. These would be definitions of people, lights, electric equipment, gas equipment, infiltration, and so on. And then you'll see further down, as an example here of electric equipment, we'll see schedules that, again, attach to all of the sub-properties of the space type, which then attaches to a space, which then attaches to a thermal zone. So what we're really seeing here is an inheritance diagram of the OpenStudio object model that relates to loads. And that's a very unique inheritance diagram in the sense that if you fully understand it, you can begin to leverage modeling with OpenStudio and making your models develop very, very rapidly, very quickly. And you do that, again, by applying a space type to a space, aggregating spaces in the thermal zones. And that's again one of the key principles in understanding OpenStudio is that some of these object model properties, they don't exist in the world of EnergyPlus. They're really a piece of the OpenStudio model object itself. So that's a big piece in learning how to use OpenStudio, is how to understand and leverage this object model. Another very unique feature of OpenStudio is a feature called Apply Measure Now. And we'll talk about measures themselves here in a few slides further, but suffice it for now, and I'll demonstrate this. Apply Measure Now is a way to automatically or programmatically inject what's called a measure into your OpenStudio model. If some of you are familiar with Microsoft Excel and Visual Basic, you may say that you've written macros in Microsoft Excel to essentially do the same thing, inject or alter your Microsoft Excel spreadsheet using a Visual Basic macro. It's the same concept here, but instead of a Visual Basic macro, we're writing what's called an OpenStudio measure. And that measure can again alter an OpenStudio model in near real time to create very rapid articulation of a model. So again, I'll demonstrate that in a few slides. A third differentiation feature of OpenStudio is the use of OpenStudio templates. And OpenStudio version 1.4 ships with predefined templates of 6 different references. And some of you, again, will recognize some of these references. ASHRAE Standard 189.1-2009. It's a high-performance building standard. ASHRAE Standard 90.1-2007 and ASHRAE Standard 90.1-2010. These are, again, energy performance or energy code compliance standards, and also 3 other standards which represent the DOE reference buildings of an older, a newer, and a mid-age standard. These are essentially collections of objects which define, again, definitions of people, lights, gains, of building form and fabric, meta properties that can be very quickly applied through objects that we saw on the last slide, for example, the space type, to attribute a model very, very quickly. So, as an example, the next slide, again, I've shown in the top right, you'll see a screenshot of 90.1-2007 and all the detail in table 5.54, which would describe how one might build a code-compliant wall, for example, or roof of a kind of a non-residential building in a particular climate zone 4. All of that information that's buried in that ASHRAE 90.1-2007, this almost 200-page document, has been encapsulated into an OpenStudio template, and that information really would allow us to create models and attribute them to, for example, code compliance or compliance with ASHRAE 90.1-2007 for our climate zone and our type of building very quickly. So that's a very powerful differentiator, again, for building code-compliant models very rapidly. Here in OpenStudio 1.4, there's a new change that's coming up. Again, I said I would demonstrate version 1.4.1 here in a few moments. And starting with version 1.4.1, OpenStudio has been designed to use Ruby 2.0. What that really means for those of us who are OpenStudio users is that we're now needing to use the SketchUp Pro software or the SketchUp Make software. And in the past, we were able to use SketchUp 8.0, and that will no longer be supported in OpenStudio versions 1.4.1 or forward. So that's a change again I want to make sure everybody's aware of, that we're using more modern versions of SketchUp that also use Ruby version 2.0. So let's go ahead and migrate now to a live demonstration of OpenStudio version 1.4.1, and I'll just start off by launching the SketchUp plugin. I'll do this again by launching SketchUp 2014. Okay, and soon we should see SketchUp 2014 launch. And I'm going to create a very, very simple building again, just to be mindful of the time we have remaining. To create an OpenStudio model here within SketchUp, we will be using the SketchUp plugin, OpenStudio plugin, which installs within the SketchUp application. And I'll start off by just creating a simple floor plan, again as simple as possible, just a 2-zone floor plan. And then I will select that floor plan, and I'm going to extrude it up just again to create a representation of a very simple building. I'll create the spaces from a diagram, a single floor building, and I've created the simplest possible building. I'm going to now just quickly draw a window on this building. I'll put a door here, and I will stop for that for now. So all we've really done right now is to generate what we call building form and fabric here within the SketchUp plugin. This SketchUp doesn't know whether this is meant to be a code-compliant office or a retail building or anything. So the next thing we would do for that would be to go in and load some predefined libraries. So for that, we're going to communicate with the building component library, and we will open up and load some space types. And in this case, I will go ahead and load ASHRAE 189-2009 space types for climate zone, say 4 through 8. Bringing those into my model so that I can assign them to the form and fabric. And then very quickly here, I will just select my spaces. Now again, these are spaces, they're not thermal zones. And I will run a routine here in SketchUp to intersect the surfaces in this model and match the surfaces, and then I will attribute these spaces. So that's very quickly, you'll see that I have the 189 space types that I loaded in, the compliant space types. If, say, for example, let's call this an office, closed office in climate zone 4, and let's make this part of a new thermal zone, and let's make it again part of an ideal air system with a thermostat associated with, again, 189 closed office. So we've done that, and now we're ready to launch OpenStudio version 1.4.1. So what I'll do now is just quickly save this file. And I'll just go ahead and save it as a name I can quickly find. And I would just go and launch my OpenStudio version 1.4.1. Now again, this hasn't been released to the public just yet, but I wanted to show it to you today as part of today's webinar. It should be released to the general. Actually, it is. It's open for. It was posted last night for the general public to download. So in OpenStudio 1.4.1 here, I'm going to just open up the file I just saved. Very simple. Just direct myself to it. And before I do anything else, I will go ahead and assign a weather file to the model. Let's put this in Chicago for the sake of simplicity. And what I want to demonstrate again is something called the Add Measure Now feature. So before I do that, I'll just put this in Chicago. Okay, now we've done that. We've loaded an annual weather file. We've loaded a design day weather file. And there's a new feature here again called Apply Measure Now. And we'll touch on this again with some more slides in the BCL, but I want to just demonstrate it. What apply measure now does, again, is it changes your model. It's basically running a macro against your model to do something, and something can be to the limit of your imagination as long as it's been coded in the context of an OpenStudio measure. So just as a demonstration now, I'm going to change the R value of the walls in my model. You may remember that I set the R value when I made this model in the ASHRAE 189.1-2009 Climate Zone 4 compliant model. It brought in whatever the compliant R values would be for that standard. I'm going to change them. And so I'm going to apply this measure, and I'm going to make my R values if my walls in my building are 50. Now again, that may be completely unrealistic, but for the sake of just demonstrating this feature, we would simply hit apply measure. OpenStudio is going to run the measure, which is again like a macro. It's a Ruby script that's executing right now, and it's changing the model. So it's changing all of the walls in my model, the 7 or 6 wall sections that I had that were associated with those spaces. I get some feedback of what happened. It looks like it started off as an R11.8, and I moved it to R50. And if I accept those changes, I now have a model that has R50 walls. And so this is a different technique again for building models. You can think again of chaining measures together. And those measures aren't limited to building form and fabric, changing the envelope properties or lights or people or internal gains. Those measures can be to the limit of your imagination. So I could, if I had more time, I could again apply a measure that would add an HVAC system to this model, apply a measure that would change the thermostat, and so on and so forth, thermostat schedules and whatever is available in the building component library in terms of measures. So that's a demonstration again of how the apply measure now feature works. So I'm going to go back to our slide deck here, and I'm going to go back now and just talk a little bit about the building component library itself, because it is another key differentiator that separates OpenStudio from all other energy simulation tools that I'm aware of. And the building component library, we just saw examples of it. We just saw a measure that was pulled from the building component library. So the library itself, what is it? Well, it's a few things. It's an internet-based source, so all of the information in the library lives on the cloud, and it's a source of consistent data. Consistent data means that again it can be defined as the standard of 189.1 or whatever component goes up there. It is consistent. It's also searchable. And most importantly, it's crowdsourced. You, I, or any of us can both remove or retrieve information from the building component library as well as submit and populate information into the building component library. And that's what's happening right now. And essentially, I look at this building component library, I call it a force multiplier, because I should have, if I think again about the number of times in my modeling career that I've basically done the same thing, not twice, not 3 times, but like several hundred times, because there was no method really available, efficient method for me to capture and automate what I had just done. And that method is the building component library. So basically, through writing measures or creating components, I can create reusable content. And that really opens up the possibility of making modeling something that's completely different than what we've thought before. It's basically creating together collections of reusable content when possible. So the building component library has 2 different really sections in it right now. Right now it stores components, which are like they sound. They would be a wall structure or an envelope configuration, a window performance, a set of values that describe a window. You know, these are literally objects that go into a model, objects that are used to create a model, definitions of those objects. And then secondly, measures. The second thing that are in the building component library are collections of measures. And measures are not just objects, they're the definition of what to do with the objects. So think of a measure as a description of a change set. I have a model, it is composed of this set of definitions, and I'd like to change it into something else. And I'm going to write a measure to accomplish that. We saw a moment ago a measure that changed every single exterior wall from whatever the R value was to whatever R value I described it to be, in that case R50. And again, those measures are written in a software language called Ruby, which is a scripting language, which if you have experience in the past and you've written VBA macros in Excel, you are qualified to write measures in Ruby scripts. It's not writing any sort of binary language or language that needs to be compiled. This is something that's accessible to almost all of us. And the most interesting thing here about the BCL, which I didn't show you earlier, which is that one of the big differentiators I keep talking about is the BCL, Building Component Library with OpenStudio, is that we have measures that are being fed into the OpenStudio, into the Building Component Library, that now don't just simply represent changing R value from X to Y, but changing the R value from X, what it is now, to some standard. And particularly the standards that are defined in the AEDG guides. That stands for the ASHRAE Energy Design Guide. And so two of those design guides, the AEDG K through 12 and the AEDG Office, Small to Medium Office Buildings Guides. Again, traditionally those are PDF documents or printed documents, several hundred pages. Those have been coded. Those have been turned into Ruby scripts. And in a drag or drop method, one can create a model that represents the AEDG performance. And then that's, if you stop and think about that, that's revolutionary. I can create a very deep retrofit or a very high performance model very quickly just by applying the AEDG measures to a base model of my existing form and fabric. So if you look again at the OS Measure Roadmap, OpenStudio Measure Roadmap, the plans here are to continue to extend the measures that are available in the Building Component Library. And I'll just remind you again, I call them force multipliers because they are what a force multiplier is. I have to put very little in and I get very much out in terms of value and content. So I would say if I were looking to use OpenStudio, I'd be watching very closely the measures that are already in the measure library, Building Component Library, and that are planned to go in the future, because those will, again, provide me a way to become much more efficient in my modeling. Just a little bit more here about the OpenStudio roadmap in general. We have, I've pulled this off the website. The roadmap is public information. It's shared on the OpenStudio website. You simply Google OpenStudio roadmap. You will go to a web page. I've just stripped this off this morning. This is the major features that are planned for the next major release of OpenStudio, which will be version 1.5, which was scheduled to be released in September of 2014. And you can see here again, additional measures will be a part of that release, additional measures for residential modeling and also for improved HVAC system articulations, additional HVAC system support, additional QA, QC, and reporting measures. So there's a big focus here by, say, mid-September, whenever OpenStudio 1.5 releases, to radically increase the number of measures that are available in the OpenStudio, in the Building Component Library. And again, I would advise us all to watch that, because it opens up the possibility of scale in a way that hasn't been present before. So I would be looking for that and seeing how that materializes. Now, there is, again, on the OpenStudio roadmap, there are further beyond 1.5 sort of fiscal year 2015 goals and things like that. I didn't pull those out because these are, again, subject to change. I would recommend anybody who's following OpenStudio closely to go ahead and watch the OpenStudio roadmap closely as well to see when new features are planned and will be released.